Welcome back. This is Mr. Hassan's Maths channel, and I'm going to be answering now question number 18 from the specimen paper for the practice paper of 2025. This is a non-calculator paper, paper 2, and this is from the Cambridge 0580 IGCSE syllabus. And here we have a question about volumes, A and B, about volumes, 18A and B. So we have a cylinder with radius 2 centimeters and height 8 centimeters, has the same volume as a sphere with radius 3 centimeters. Find the value of h. So we need to know about the volume of cylinders and the volume of spheres, okay, for us to be able to deal with this question. Now, in the past, volumes of cylinders were not given. The formula for volume of cylinder was not given, but volumes of spheres were given. Now we have both of them in the formula sheet. So we go back to the second page. We see we're given all of these formulae here. So you got the volumes of areas of triangles, circles, circumference of circles, curved surface areas of cylinders, curved surface area of cones, surface area of spheres, volume of prisms, volume of pyramids, volume of cylinder. Now this should really be enough for us for the volume of a cylinder, because it's like it's a prism. The cross section area was a circle, so it'd be pi r squared times how high it is. But this is what we're looking for here. They give us a formula for cylinder, pi r squared h, and the volume of a cone, a sphere, 4 over 3 pi r squared, pi r cubed. So these are the two formulae that we need in this part of the question. Okay, volume of a cylinder, pi r squared h, volume of a sphere, 4 over 3 pi r cubed. That's what we need for part A of this question. So that's something that in the past you would have had to actually have memorized those, but now we can just look them up. Actually, well, the cylinder you'd have to memorize. The sphere would have been given in the question itself. So the volume of a cylinder, as we just saw, is equal to pi r squared, that's the cross-sectional area, times h. Remember, a cylinder looks something like this. Okay, it's like a circular prism. So it has a cross-sectional area, which is like a circle times how high it is. That's the height, that's the radius, pi r squared h. And the volume of a sphere, now a sphere is like a 3-dimensional circle, it's like a ball shape, is 4 over 3 times pi r cubed. All right, so they've told us that the cylinder with radius 2 and height h has the same volume as a sphere with radius 3, and we want to find the value of h. Okay, so basically, want to find the value of h, so pi times r squared. Now this is the radius of the cylinder, which is 2, pi r squared h. Okay, we have to find what h is. That is equal to the volume of the sphere, which is 4 over 3 times pi times r cubed. This is going to be 3 cubed. 4 over 3 pi r cubed. Now, in the past, we would use calculators, and this is our calculation. We'd have to really think too much about it. We just plug in numbers and stuff, and we'll get the answer. Now, because we have the non-calculator paper, we have to try to think of ways of making our life easy for ourselves. So first of all, you see there's a pi on both sides. Okay, there's one term, pi. We divide both sides by pi, the pi's will cancel out. Pi, remember, is just a number, it's a constant. And then we see over here, there's 3 and there's 3 squared. Well, 3 cubed, sorry. 3 and 3 cubed cancel out to give you 3 squared. So that might make life a little bit easier as well. Okay. And here you have 2 times 2, which is 4. 2 squared is 4, and this is 4. They will also cancel out. So you can, before we actually start, we can cancel out everything, and h is equal to 3 squared. So h is equal to 9. Do we write centimeters? No, because the centimeters is there already. So h centimeters, so h is 9. That means that would say 9 centimeters. So that's all we do here. That's the answer. So you see that the calculation became very easy, although it looked like it might be complicated. How are you going to deal with this without calculator? But it's actually quite simple. This becomes 4. This is 4. They cancel out. This is pi. This is pi. This cancel out. 3 and 3 cubed become 3 squared. 3 squared is 9, and we've got our answer. Okay, so there's the answer to part A. Okay, now for part B. It says a solid metal cube has sides with length 20 centimeters. Okay, so you have a cube. A cube is like cuboid, but all the sides are the same length. So the volume of the cube would be 20 cubed. The cube is melted down and made into 40 solid spheres, each of radius r centimeters. Show that r equals cube root of 150 over pi. So basically all of the metal cube is melted down and made into these spheres. So we can say the volume of 40 cubes is equal to the volume, the volume of 40 spheres, I should say. The volume of 40 spheres, okay, let me spell that right, bit of a mess. The volume of 40 spheres is equal to the volume of the cube. Okay, so you have 40. As we learned, the volume of one sphere is 4 over 3 pi r cubed. And that's equal to the volume of the cube, which is 20 cubed. Okay, so we want to find r, or show that r is equal to the cube root of all of this. So we're going to try to simplify this. Now, 40 times 4 is 160. So you have 160 over 3 times pi r cubed equals 20 cubed is 20 times 20 times 20. That gives you 8 and 3 zeros. So it's 8,000. As we know, 20 times 20 times 20. You have 2 times 2 times 2, which is 8. And you have 3 zeros, so 8,000. Okay, so now we can rearrange this for r cubed. So r cubed is going to be 3 times 8,000 over 160. Okay, over 160 and pi. 160 pi. Okay, so we can see here that a 0 can cancel with a 0. And we know that you got 16 goes into 80 5 times. I know that. We can break it down even simpler if you wanted to. You could say, for example, 8 goes into 16 2 times. Okay, so, and then you can say that that's a 10 here, and 2 goes into 10 5 times. 3 times 50 is 150, and this is all being cancelled out over pi. So we can say r cubed is equal to 150 over pi. So therefore r is equal to the cube root of 150 over pi. So it's important that you show these steps here, because the answer is given already. All right? It's important that you show these steps here. Very important that you show them clearly. Okay, maybe I could have shown this a bit clearer than this, but you know, that's how I'm going about doing it. So I mean, maybe you could have done 3 times 8,000 over, and I could have written this as 4 times 40 times pi. That would have been maybe a bit easier for us to show the cancelling out. Like 40 goes into 80 2 times, okay, and we can say here that 4 goes into 25 times. 3 times 50 is 150, 150 over pi. There's different ways we could have done it, but this seems to be fine. So there's the answer to part B. So part A and B are about volume. Part C is about surface area. So what I'm going to do is I'm going to save part C in a separate video, because I'm going to have different playlists, some to do with volume, some to do with surface areas. So I'd like to keep that in a separate video for topics, but it will be in the same playlist as this paper. If you want to see the other questions on this paper, you go to the playlist at the top right of the screen at the end of the video. You want to see the playlist dealing with volumes, you go to this particular playlist down here. My mensuration kind of videos all together. You'll find them in the top over here from the new syllabus. And my old syllabus volume kind of questions will be in this playlist over here. So a lot of the old questions will be relevant to this. The only thing that won't be relevant is how to deal with things when you have no calculator. That's the only thing that's kind of newish to the skills that we have to know in this because of the new syllabus. Okay, so thank you for watching and see you soon.